Hello everyone, and to all those curious about the greatest mystery of human nature. Today, we'll explore the triggers of the cognitive revolution that massive mental leap Homo sapiens experienced roughly 100,000 years ago. It wasn't just biological changes that transformed us. It was also the emergence of symbolic thought and complex language. Climate pressures and strengthening social bonds accelerated our brains like data processors. What do you think has the greatest impact on human nature? It's always a pleasure to read your comments. 100,000 years. That number sounds huge, but in the grand scheme of evolution, it's just a blink of an eye. Dinosaurs showed up 160 million years ago. The first mammals evolved about 25 million years ago. Our ancestors, the hominins, split from the great apes around 6 to 7 million years ago. But around 100,000 years ago, something changed. People who were almost anatomically identical to us in height, same skull shape, same hands, suddenly started acting differently. Their tools got more complex. Art appeared. Symbols showed up. It was used. People started migrating to distant lands, and from a geological perspective, it all happened almost instantly. This story isn't just important for understanding the past. It's important for understanding you. Your ability to read right now, your imagination, your capacity to love, your ability to suffer and make sense of pain, all of that is the result of a process that began 100,000 years ago. The people who lit fires in those ancient caves were your ancestors. Their fears were your fears. Their hopes were your hopes. And the fact that they were able to make this huge leap, proof that you can create meaning in this world too. So keep going, keep listening, because by the end of this story, you'll see yourself in a whole new way. Now, picture yourself 200,000 years ago in East Africa. You're standing in the Great Rift Valley. All around you stretches an endless savanna. The sun is blazing right overhead, and the hot air is filled with the mix of dust and the smell of grass. In the distance, you hear the hum of a zebra herd. You're part of a small group, maybe about 20 people. You're a hunter, a gatherer. Most of your day is spent searching for food. You're going through life, protecting the kids, feeding the weak, avoiding predators. This is your everyday reality, and it's not much different from the other species around you. But something's brewing inside. New connections are forming in your mind without you even realizing it. New thoughts are sprouting. There aren't words for these thoughts yet. No names yet. But something is changing. The first Homo sapiens appeared around 200,000 to 300,000 years ago, found at the Jebel Irhoud excavation site in Morocco. Fossils pushed this history back to about 300,000 years ago. But these early Homo sapiens acted pretty differently from modern humans. They made tools. Yeah, they used fire. They hunted animals. But those tools barely changed for hundreds of thousands of years. The same hand axes, the same simple cutting stones, the same rough techniques. It was like they were stuck in one place, like there was some kind of lock in their minds that just hadn't opened yet. For archaeologists to understand this stagnant period, they had to look beyond just the tools. And when they looked, they saw unexpected things. In the Pinnacle Point Cave in South Africa, traces of pigment paint dating back 106,000 years were found. People were using red mineral paints. Why? It wasn't directly about survival, but it had symbolic meaning. Maybe it was applied to the body or used to paint objects. In the Blombos cave, geometric patterns from 77,000 years ago were discovered. On engraved pieces of ochre, it wasn't changes in skull or bone density, but a change in behavior that was starting to show. This behavioral change doesn't show up in any fossil record, and that's where science hits its limits. Fossil records show us the bones, but they don't show thoughts, dreams, or conversations. So, it's incredibly hard to pinpoint exactly when the human mind changed. But there is indirect evidence, and that indirect evidence tells us that something fundamentally changed between 100,000 and 40,000 years ago. Researchers call this change by different names, like behavioral modernity, the Upper Paleolithic Revolution, the Cultural Big Bang. Whatever you call it, the truth is, during this time, humans started becoming more than just humans. Now, I'm going to tell you about the most crucial part of this big change, language. And when I say that, I don't just mean making sounds. Animals make sounds too. Dolphins make really complex noises. Chimpanzees can learn sign language. But human language is something else. Human language can create an infinite number of new sentences. People can talk about things that aren't even real, like when the sun rises tomorrow morning on the other side of the river. Say something like, "Let's meet at the corner." This sentence has future tense, a condition, a place, and a social agreement. No other creature can put together a sentence like this, and this ability completely changed survival strategies. Before language, humans only lived in the present. If there was danger, they ran. If they were hungry, they ate. If they were sleepy, they slept. But when language came along, time expanded. The past could be remembered and shared. The future could be planned. The idea of a place where fruits ripened this season last year came into being. The idea of coming back in spring was born. And even though it seemed like a small change, it was actually an existential transformation. Because from then on, each generation didn't have to start from scratch. Everything learned by one generation could be passed on to the next. And knowledge started to build up. Culture was born. So, how did language come about? This is one of the biggest debates among linguists and evolutionists. Fossil records don't give direct info about language, since vocal tissues don't fossilize. But there are indirect clues. Skull. The shape of the base gives clues about how the vocal tract evolved. The hyoid bone, a small bone that supports the tongue muscles, has a structure in humans and Neanderthals that's similar to that of modern humans. This shows that the physical setup for speech was ready at least tens of thousands of years ago. But having the physical parts isn't enough on its own. The brain areas that process language also need to develop. The Broca's area and Wernicke's area, these two parts of the brain, are the keys to human language. Broca's area is responsible for producing speech. The area is related to language comprehension. And in other primates, these areas are either absent or much smaller. At a certain point in human evolution, these areas grew and the connections between them strengthened. Phonology, syntax, semantics, all these complex language skills require different parts of the brain to work together smoothly. And from an evolutionary perspective, this coordination is almost like a miracle. One of the most interesting language theories suggests that language developed out of the need for gossip within social groups. According to Robin Dunbar's theory, in primates, the way to strengthen social bonds is by grooming each other. Monkeys spend hours cleaning each other's fur. This is crucial both for hygiene and for building social connections. But as the group gets bigger, it becomes impossible to physically groom everyone. Language solves this problem. Talking is a way to connect with multiple people at once, and conversations about who's behaving how, who's trustworthy, and who's doing what are actually the most efficient way to share social information. It might sound trivial, but this actually lays the foundation for large-scale collaboration. If this story has fascinated you so far, go to the comments now and tell me this. What do you think is the most fundamental thing that sets humans apart from other species? The answer to this question will shape the topic of my next video. Don't forget to like the video and subscribe to the channel, because these deep dives take a lot of effort, and every like helps keep this work going. Fire is maybe the most important technology in human history, and it goes back 100,000 years. Technology was being used in a way that was way more organized now. But fire wasn't just important for keeping warm or scaring off predators. Cooking, Richard Wrangham, an evolutionary biologist from Harvard, did a deep dive into how cooking played a role in human evolution and came to this conclusion. Cooking made our brains bigger. Cooked food has way more digestible calories compared to raw food, and those extra calories went straight to fuel our growing brains. Even though the brain makes up only about 2% of our body weight, it uses a huge chunk of our total energy. It uses 20% of your energy. Growing such an energy-hungry organ needs extra resources, and fire provided that. But fire has another side, maybe even more important. Thanks to fire, humans conquered the night. Other animals either sleep at night or hide from dangers in the dark. But humans gathered around the fire and stayed awake all night. Those nighttime hours became story time. In the flickering firelight, the oldest and wisest in the group shared their experiences. Last year's huge flood was talked about. They shared how they dealt with a dangerous hunter. There was gossip about people from far-off countries, and tonight, stories became the strongest way to keep culture alive. Oral tradition started thousands of years before books and kept human knowledge alive through generations. Now, here's an amazing discovery. Sibidu Cave in South Africa is a site from 77,000 years ago, and excavations there uncovered carefully chosen plant layers used as bedding. It's not just any plant, but plants that keep bugs away. So, 77,000 years ago, someone thought, if I put this plant by my bed, bugs won't bite me. That's cause and effect. If I do this, then that happens. It's the most basic form of abstract thinking, and this idea blossomed in that cave as the result of millions of years of evolution. It might seem like a tiny detail, but the mental leap it represents is huge. What do you think when you hear the name Neanderthals? Maybe they were rough, primitive, big-headed cave people. But this picture is mostly wrong. Neanderthals were smart. They made tools, and their tools weren't far behind the early Homo sapiens tools. They used fire. They buried their dead. There's even debated evidence that they put flowers in graves. They took care of sick and old group members because fossils show individuals who wouldn't have survived without care. They weren't primitive. They were social, empathetic, and thoughtful. Assets. So why did they disappear? This is a question paleoanthropologists have been debating for decades. When Homo sapiens entered Europe around 40 to 45,000 years ago, Neanderthals were already there, and just a few thousand years later, Neanderthals vanished. Was there a clash? A war? Maybe partly. Or did disease spread? Probably. But the strongest theory is this. Homo sapiens had way better social organization skills than Neanderthals. Homo sapiens could work in bigger groups. They were able to build more complex trade networks. They could even cooperate with strangers around shared symbols. And this difference in capacity was a game changer in competition. Oh, here's an interesting detail. In the DNA of modern humans, all populations except Africans have about 1% to 4% Neanderthal DNA. That means our ancestors mated with Neanderthals before they disappeared. Some of the genes passed on from these unions are still with us today, especially those related to the immune system. Neanderthals had adapted to Europe's harsh conditions over centuries, and those adaptations got passed down into Homo sapiens genes. So, Neanderthals didn't completely disappear. A part of them lives on in us. That's a pretty profound truth. Now, let's focus on something that happened 45,000 years ago. Homo sapiens were reaching Australia, which was a big turning point. Getting there meant crossing open ocean. During the Ice Age, sea levels were lower, so some islands were bigger than they are today. But still, crossing the sea to an unseen continent took guts. And people did it. They built rafts or canoes and headed out into open water. It was a mix of planning, foresight, and bravery. And when they reached Australia, they encountered giant animals that had never seen humans before. 2-ton kangaroos, 3-meter-long lizards, huge wombat species, all of them disappeared within a few thousand years. Wherever humans went, they transformed ecosystems. This great migration is also a genetic masterpiece. At the same time, it involved a small founding population. Humans originated in Africa, and this small group spread across the whole world. They adapted to new conditions in every region. Their skin pigmentation changed. The ability to digest milk as adults, called lactase persistence, developed in certain populations. Adaptation to high altitudes appeared in Tibetans. Adaptation to cold was seen in Northern Europeans and Arctic peoples. Every new environment brought new evolutionary pressures, and humans responded each time. This flexibility is humanity's greatest strength. It's not about being fixed, but about adapting. Let me tell you about one of the biggest secrets of genetics. Certain parts of the human genome have changed insanely fast during evolution. These areas are called human accelerated regions, and most of them are linked to genes involved in brain development. Think about it. Evolution usually works super slowly. A tiny change in a gene can take millions of years to spread through a population. But in these regions, changes happened at lightning speed by evolutionary standards. So why is that? Was there a strong selection pressure? Did smarter individuals survive and reproduce more? Or were other mechanisms at play? These questions still don't have clear answers, but clues are piling up. One of these clues is about the neocortex, the brain's outermost and newest evolved layer. Planning, reasoning, language, abstract thinking, art all happen here. To increase this layer's surface area, the brain forms folds. More folds mean more surface area, more neurons, more processing power. The human brain's capacity is insanely complex compared to other primates, especially when you look at how much it folds. It's no coincidence that the genes controlling this folding are among the fastest evolving in human history. Take a look at Europe 35,000 years ago. Homo sapiens had been living there for tens of thousands of years, and during that time, what's called the Upper Paleolithic period kicked off a major turning point. There was an explosion of cave paintings, Lascaux, Altamira. The artwork in these caves is absolutely mesmerizing. Not just beautiful, but truly captivating. Not because they are old, but because they're technically amazing. The animal's movements are shown in 3 dimensions. The natural indentations of the rocks are used to create a sense of depth. Some figures are drawn with multiple legs to give the impression of movement. This is an artistic approach. This is aesthetic awareness. And that's why some researchers see cave paintings as the peak of humanity's first symbolic revolution. Were the paintings in these caves made just for beauty, or did they have another purpose? That question is still. It's being debated. Some researchers think these paintings were made for ritual purposes. Hunting rituals, symbolic acts meant to bring abundance. Others suggest these paintings were a means of communication, to store or pass on information, like which animals live where, what seasons are best for hunting, what dangers are around. And some researchers have an even more interesting theory. These paintings document the discovery of consciousness. For the first time, humans stepped outside themselves and watched themselves. Handprints on the walls, hand silhouettes on the wall. I was here. I exist. The most primitive, powerful way to say that. Think about a handprint made 40,000 years ago. Someone took paint into their mouth, blew it onto their hand on a cave wall, and that hand silhouette is still there. 40,000 years later, you see it and share something with that person. They didn't know you would see it, but they left it. They left a mark, proof that they existed. It's one of humanity's most basic urges to be remembered, to leave Minevan knowing we're mortal. It's about creating something from scratch. And this urge goes back to the big leap that happened 100,000 years ago. They found flutes that are 35,000 years old, made from bird bones with 5 holes, and the sounds they produce match the musical scales we use today. So, those people heard the same melodies we do now, the same harmony, the same sense of rhythm, the same musical vibe, something that hasn't changed for tens of thousands of years. And this unchanging nature shows just how universal and deep-rooted humanity's basic experiences are. Why is music universal? Every culture, every era, every place has music. There's never been a human society without it. That can't be a coincidence. Music must respond to a deep need in the human brain. Emotional connection, social bonding, group harmony, and maybe even meaning. Let's go back to Blombo's cave. It holds one of the clearest proofs of humanity's big leap forward. There are workshops from 75,000 to 100,000 years ago where they processed ochre paint. A red mineral called ochre was ground up with pieces of bone. It was being mixed and stored in warehouses. This was part of a production process. Getting raw materials, processing them, storing them, using them. This whole process is proof of abstract thinking. Also, in the same cave, they found 75,000-year-old seashell beads. They were pierced and strung together, probably made into a necklace or bracelet. Think about it. Why did the person string these beads? Did it help them survive? Stay warm? No, but maybe it showed they belonged to a group. Maybe it signaled their status. Or maybe it was just for aesthetic pleasure. It meant that maybe someone had given it to a person they loved. Hundreds of thousands of years ago, one human gave another a fancy bracelet. This idea says something deep about the essence of humanity. Loving, giving gifts, sharing beauty. These are all part of a huge leap for mankind. Evolution isn't just about the strongest surviving. It's also about those who connect, love, and find meaning surviving. Because social bonds made survival easier. Networks of trust, helping each other, Emotional connections. These are real evolutionary factors. There were advantages, and that's why humans evolved to love each other. Isn't that such a beautiful truth? Now, let me tell you about maybe the most important aspect of humanity's big leap: the ability to believe in shared stories. Israeli historian Yuval Noah Harari explains it like this: humans are the only creatures that can believe in things that aren't real. Gods, nations, money, companies, laws, human rights, none of these exist physically. You can see a rock, you can touch it, but where exactly is a nation? Or what's the real value of a currency? These ideas are shared stories, living in the minds of millions, and these shared stories move millions of people together. How were the pyramids built? Thousands of workers came together around a shared story, the divine authority of the pharaoh. How does today's global economy work? Billions of people share the belief that a piece of paper, like the dollar, has value. It's incredible. And this ability to create shared stories started 100,000 years ago. When symbolic thinking developed, humans not only it started to represent not just what was seen, but also what couldn't be seen. A carved animal figure didn't just stand for that animal, it embodied its spirit, strength, and meaning. This ability to symbolize became the foundation for all human institutions: religion, mythology, law, economy, politics, art, and science. Everything you see in the world today is a distant descendant of that symbolic thinking revolution. To understand the Neolithic revolution 10,000 years ago, you have to look at it this way. The start of farming. Why did people shift from hunting and gathering to farming? This shift isn't as straightforward as it seems. At first glance, farming looks easier, but it's not. Hunter-gatherers worked about 4 to 6 hours a day. The rest of the time was for socializing, playing, and resting. The first farmers, on the other hand, worked from morning till night sweating. Plus, their diets became more monotonous. They got shorter and their resistance to diseases dropped. So why did the change happen? Probably because of population pressure. As groups got bigger, the land for hunting and gathering shrank, and farming opened up a way to feed more people on a smaller area. But this shift also brought along the idea of ownership, permanent settlements, hierarchy, and all the other key foundations of civilization. Writing appeared about 5,000 years ago in Mesopotamia, and with it, humanity's knowledge took on a whole new level. Now, not just stories told aloud, but things written down could be passed on. A record of debts and credits from a Sumerian trader 3,500 years ago can still be read today. A poem written by an Egyptian scribe 4,000 years ago still amazes people today. Knowledge was no longer tied just to living beings. It could exist independently. It was the invention closest to human immortality, and an inevitable result of that huge leap that started 100,000 years ago. Because without language, there's no writing. Without symbolic thinking, there's no alphabet. And without that revolution 100,000 years ago, none of this would exist. Now, just stop for a moment. When you put all this information together, what do you see? There's a domino effect. Language developed. Language made it possible to transfer knowledge. Transferring knowledge kicked off cultural accumulation. Cultural accumulation led to more complex tools. It made it possible. More complex tools led to better nutrition. Better nutrition grew the brain. A bigger brain made more complex language possible. More complex language allowed for larger social groups. Larger social groups allowed for more complex division of labor. More complex division of labor created specialization. Specialization sped up technological progress, and this cycle fed itself all the way to today. You're part of this cycle. You're a product of this cycle. Now, at this point in my video, I want to ask you something. I'm really curious. Write this in the comments. If you lived 100,000 years ago, which skill would you want to discover? Language, fire, art, or something else? And don't forget to like and share this video, because more people need to see these deep dives into history and science. Now, let's keep going, because the most shocking part hasn't come yet. The connection between climate change and human evolution has become way clearer thanks to research done over the last decade. 100,000 years ago, the world was very different from today. The climate was different and way more unpredictable. Ice ages came and went. Large parts of Africa would sometimes turn into desert, then become lush and green, then dry out again. Lakes would fill up and overflow, then evaporate and disappear. Forests would turn into savannas. Then savannas would turn back into forests. In this constantly changing environment, there was only one strategy that worked to survive: adaptability. In a stable environment, the best strategy is specialization. Specialize in eating a certain food, living in a certain climate, and do this really well. But specializing in a constantly changing environment is a death sentence. In a changing environment, you need to be general purpose, flexible, and able to adapt quickly to new conditions. And the human brain actually evolved exactly for this kind of flexibility, coming up with different solutions for different problems, recognizing new situations, learning from past experiences, predicting the future. These are all skills demanded by a changing environment, and they became critically important around 100,000 years ago. So, some researchers call this period variability selection. The hypothesis explains variability selection. According to this theory developed by Richard Potts from the Smithsonian Institute, the human brain didn't evolve to adapt to a specific environment, but to adapt to any kind of environment. This metadaptation ability made humans the only species that can live in every environment on the planet. From the poles to equatorial deserts, from sea level up to 4 kilometers high, humans live everywhere. No other large mammal occupies such a wide ecological niche. And underneath all this is that flexibility evolution that started 100,000 years ago. Now, I'm getting to the most debated topic: consciousness. Being aware of yourself, knowing who you are, remembering your past and planning your future, knowing you'll die but still searching for meaning. But this ability is the deepest part of the big leap that began 100,000 years ago, and science still doesn't know much about it. Neurology tells us which parts of the brain get involved, but this neurological activity is tied to a subjective experience. It still can't explain how perspective turns into an inner voice, a sense of self. This problem is called the hard problem in consciousness studies, and maybe its answer holds the ultimate secret to humanity's big leap. But here's what we do know. Consciousness made large-scale cooperation possible. A being aware of itself and others can empathize. It can guess what someone else might be feeling. It can see things from another's point of view. And this ability to empathize is the most complex form of social animal behavior. The foundation of human society, thinking about what's good for the group, not just what's good for the individual, isn't possible without conscious empathy. That's why consciousness isn't just a philosophical question. It's the key to humanity's evolutionary success. Now, let's talk about today. The era we're living in is moving faster than anything we've ever seen in history. Computers, the internet, artificial intelligence, gene editing, technologies, all of these have built on the knowledge of that first human who made stone tools. And this momentum keeps growing. Every 10 years, knowledge. They used to say it was doubling. Now it's happening way faster. No one knows where this speed will take humanity, but one thing's for sure. It all started about 100,000 years ago with a small group of people sitting around a fire in a cave. And if we've come this far from there, we can keep going even further. But there's a warning in this story too. Humanity's big leap gave people incredible powers, but those powers weren't always used for good. The same language that made cooperation possible also made lying possible. Symbolic thinking is what gave birth to art. That same symbolic thinking also gave rise to ideologies and propaganda. The same capacity to organize is what built civilizations. That same capacity built war machines, too. Humans are the only beings equally capable of both good and evil. And this dual capacity is part of that great leap that started 100,000 years ago. The future of humanity depends on which of these two capacities takes the lead. And that choice falls on every generation, every individual, again and again. Who are you? Ask yourself that question. You're made of atoms formed from stardust that's billions of years old. These atoms travel through the Earth's depths, seas, and plants for hundreds of millions of years. Then, one day, they became part of a human body. A body that's the result of an evolutionary process that started 100,000 years ago. But you're not just matter. Because this matter thinks. This matter loves. This matter searches for meaning. And that's why you are a point where the universe is trying to understand itself. That's not small. That's incredibly big. We've come to the end of this amazing journey. We've been roaming for 100,000 years. From the African savannas to the caves of Europe. From the coasts of Australia to the mountains of Asia. From stone tools to musical instruments. From paintings to writing. From small hunting groups to billions in human civilizations. And at the heart of this entire journey is just one thing: the search for meaning. Humans were born as beings who seek meaning, and this quest has carried them beyond every obstacle. Today, you are the latest link in that search. But you're not the last link, because this chain will continue after you. Hari, it's my pleasure to share this story with you. It gains new meaning every time. Whenever I read any research about human evolution or follow every new fossil discovery, I feel something. A deep respect. Respect for our ancestors. They had no resources, no guarantees, yet they fought every day just to survive and left this legacy to us. And we carry this legacy. Passing it on to the next generation is all our responsibility. What can we learn from this great journey? Change is born under the greatest pressure. Humanity's big leap wasn't easy. These weren't just ordinary times, they were lived right in the middle of climate crises, famines, and the struggle to survive. Seeing the seed of growth amidst hardship. That's one of the big lessons we've learned from humanity's great leap forward. Sticking together is the strongest way to survive. A single person was nothing, but when people came together around a common language and shared vision, the human race changed the world. The search for meaning isn't a luxury, it's a necessity. Humans can't live without meaning. These three lessons were written 100,000 years ago, but still true today. If this journey moved you, if this story sparked something inside you, this completes the great evolutionary leap by which the human mind emerged from darkness into light. Our lives gained meaning through the symbols found in the earliest cave paintings and the unifying power of a shared imagination. It was through the culmination of our biological evolution with a social and mental revolution that we truly came to understand what it means to be human. This momentum is the cornerstone of the civilization we are building today. I hope you have enjoyed this fascinating journey of discovery. Take care until our next journey.